So for today, we will concentrate on finishing finish finishing the discussion on the uh, trust. Then, if we have time, then we will discuss some theory on the frame as well. Okay. So for this one, who just now say that you have a problem with problem number one? Hello. Just now who say that you have problem with number problem one?
Me, sir.
Okay, Omar. uh, why you have a problem with this one? Which one confuse you?
I think I just don't know where to cut it in case when I use section method. I don't know where to cut it.
So basically, if you are asked to finish it using join method, you'll be able to do so, correct?
Yeah, but it
will be too long, right? Yes, correct. So question here is we have to find out the forces in the member of the member CH and BH. Okay, BH. So this one and CH. CH, this one. Correct, right? Those two members, right?
Yes.
Okay. So what do you think where we should cut it, Omar? Any idea? No idea yet?
No.
Okay. So basically, it's like this. Sometimes some of you will think that okay, one cut supposed to be enough, right? One cut supposed to be enough to finish the whole problem. Correct, right? I believe from the beginning that's your mindset, right, Omar?
Yes, sir.
So one cut to solve everything, correct?
Yes, sir.
But sometimes we can't do so. Okay. Before you can do the cutting here, if you want to cut here, like most likely we have to cut at least 3 members, right? So in that case, the first thing that you're supposed to do, you have to solve for this one and this one. You get it? Have you solved it? Omar?
Yeah, yes, sir.
Yeah. So the first thing is you're supposed to solve for Fy and Ax, and A. Right? You get it?
Yes.
Yeah. After your results, then you can do the cutting. Okay. For everybody else, you have any question in the middle of my explanation, you can just turn on your mic and meet me. Up until this point, anyone here still have a problem finding the Fy and Ax? Nope. Okay then. In that case, I will continue. Then the next one, after you find out the Ay, Ax, Fy, then the next question is where we're supposed to cut it, right or not?
Yes, sir.
Okay. In order for us to be able to cut, okay, how many members that we can cut, Omar?
How many members?
Remember that we have actually we can cut in 3 members, but if you just want to use one side of the body diagram, then this one is enough. Okay, you have this equation, right? So basically, if you just want to use one side of the free body diagram, then you will be only left with 3 equations, correct?
Yes, sir.
In that case, it will be better for you if you can find okay, only 3 members to cut.
Okay.
That's the idea. So basically, whenever you want to use a section method, just try your best to find only 3 members. The cutting line where it's only 3 members.
Okay.
Okay, because we try our best to only use one side of the diagram. We don't want to use both sides of the PPA diagram, because if it's both sides of the PPA diagram, I believe the calculation will be quite complex.
Mm-hmm.
Okay, so you're only left with the 3 members to cut. That's the best way. And now the problem is, like what Omar said at the beginning, it is very hard to find three members, okay, here that we can cut in order to solve TH and CH directly, right, Omar?
Yes, sir.
Then, anyone here have any idea on how to solve this then? Please help Omar. Okay, William Chwanda, can you help Omar?
Yes, sir. We can cut in I, HC, and DC.
HI, HC, and C. Okay.
And CD.
So CD, okay. And how about EH then? How can we find the force at EH then?
What's the TH?
TH. TH is part of the question, right?
Yes. Oh, yes.
You can combine, William. You can combine between the cutting method, between the section method, and the join method. That's the thing that we're supposed to do, Omar. Okay. So the first thing that you can do, right? Try to find 3 members that you can cut to at least solve the problem. To solve some of the problem. Okay.
So
in this, yeah.
So we use section method to find CH, and we use join method to find DH.
Correct. You can do it that way. So like this. So this is the first cut. Okay. Then you can solve for the you can solve for CH, you can solve for DC, right? Then just join method here.
Okay.
In that case, you save quite a lot of function in comparison to just join method from the beginning, right?
Okay. Yes, sir.
Yeah. Okay. Yes, I think that's. Do you get the idea, Omar? Do you need me to do it for you? No, you don't need, right?
I think I get it, sir.
So basically, you cut it, right? You will left with this 2 free body diagram. This one. This is first free body diagram. A and Y, X. Okay, we assume that you already finished the calculation for MYAX. Okay, then CT, CH, HI. HI, then CTH. Okay, wait, CTCH. So something like this, CH, and I. Okay, so from one is not, it's not supposed to be there. From this free body diagram, you find these three, right?
Yes.
Then after you find those three, then you can go for Joji.
Okay.
Okay, because C is known, right?
Yes.
So then later you will have is like this. CD is known, and my assumption is tension, so it's like this. FCD, one is 50 kilonewton. Yeah. DH and DE. Okay. DE, DH, DH, F, DE. Okay. DH is the one in DH is the one in question, right? Okay.
Yes.
FCD is known already. So then you left with two unknowns, right? Sorry, CD here is not supposed to be going to the right. I'm sorry, I made a mistake. This one is supposed to be going like this. Okay. This one is using join method.
I see.
Okay, so you can combine it. You know what?
Yes, sir. I get it, sir.
You can combine both methods. So you can use the best possibility to use a section method. Then if it's not possible to solve all the problems in method, then you can combine section and join method.
Okay. I get it, sir.
Sometimes you can even do the double section method.
Okay.
So sometimes, for example, if the one in question is ED, CH, HI, and the set is ED, EF, and GH like that, then you can do like this. This is the first cut, and this is the double cut. The second cut.
Oh, I see.
It's okay. It's okay to do so. You are allowed to do so. Okay.
Okay. I understand, sir.
Good. Okay, and one more thing, when cut, okay, when you do the sections, try your best to make sure that both sides of the body diagram, the left side of the cut, and the right side of the cut has some kind of rigidity. In that case, then you can confirm that your your cutting method somewhat, how to say, valid like that. So for example, using our first cut just now, this one, the first cut like that, the right side of the free body diagram is like this. Okay, so you can see that there is some kind of rigidity there. And we know that this particular structure is free because actually that one represents this, right?
Yes.
So we know that it's rigid. Then the second free body diagram actually will represent this. And we know that it's rigid as well. Correct, right, Omar?
Yes, sir.
Yeah, so it's supposed to be valid to cut it there. Okay. Yeah, because there are so many questions with the homework, then I will try to explain about this as well. Any one of you have a problem with this particular question? Determine the force in member FICG. FI, where is FI? FI is here. Then CG is here. Okay. What do you think, Omar? Yeah, can you solve this one?
Yes, sir.
So,
I
what kind of method did you use here?
For the CJ, I use the join method, but I think it can be solved with section method. For
Okay.
FI, I use
CJ method. Okay.
the section method for FI.
CJ method. Using which point?
A AJ, I got because I think the BJ is zero first member, right? And
Yep, correct.
in the AK and
As
J
usual, yes.
zero first
As
member
usual,
too.
you should determine which one is zero first member. Actually, in the previous problem as well, we have zero first member here. But for these particular things, actually, we solve it without considering that one as a zero first member. Okay, because this one, right? This one is actually zero first
Yes.
member.
BJ.
Yeah. For this one, yes, BJ is zero first member. Then after that,
AK and JK.
AK and JK. Oh yeah, correct. That one is zero first member as well. This is the first type of zero first member. Okay, the type of zero first member. Oh, sorry. Then this one is the type of zero first member. Okay, so those three are zero first member. Yeah. Okay.
Yes.
Then after that,
I determine AX and AY.
AXAY.
And then I'll go to join J.
Join what?
Join
J. Join J then you go to join A first.
Oh yeah, join A first.
Okay. Solving for join A, then after that, after solving for join A, then you can solve for join J. Yes, correct. You can do it that way. Then the second part, FI, how can you solve it?
I'll cut
Like this.
F, yeah, the FI and HI.
Okay, yes. You can do it that way as well. Yep, you can do it that way. CJ, yes. Okay. Or the other thing that you can do without once again without determining whether the BJ, JK, and AK zero force member, actually besides cutting here, this is the first cut, then you can solve it using double cut like this. This one can solve for the problem as well. Okay, Omar?
Yes, sir.
Okay. Anyone have any problem with the number 2 here?
Sir, I have a question.
Mm-hmm.
Why is AK a zero first member? Isn't it
AK, JK, yeah. AK and JK is zero force member because if you take a look at join K, right? If you take a look at join K, actually it will be like this, right? This one is AK, this one is JK, right? Okay.
yes?
So at join K, yeah, there are only two members going through that particular join, right? Join
For this one, right?
AK and JK, right? This one, this particular join.
Yes.
Okay. So if
Yes,
you take a look at that, and if you use sigma Fy and sigma Fx equal to 0, like it or not later, both of the results will be 0. Fjk equal to 0, Fak will be equal to 0 as well. Because the vertical component will only belongs to Jk. The horizontal component will only belongs to AK.
For AK. Okay,
And-
I see.
And this one is considered as the first type of the first member.
Yes, yeah.
If you remember the my explanation last week or weeks ago, this is the first type of zero force member.
Yes, sir.
PK.
I thought it wasn't allowed because this one, sir, because there's a pin. Because there's a pin.
No. You
So I
you don't
thought
have to
it's
care. You you don't have to care about your pin. Okay, what you should care about is pin K. Pin. Sorry, you don't have to care for pin A. You should care about is only pin K. So once
yes, sir.
from one particular pin, you can determine that a member or several members are zero force. Then it is zero force. You don't have to take a look at the members. You get it?
Yes, sir.
So
Yes,
it's not the other
I
way around.
understand, sir.
Okay, because of joint A is like that. Okay, then there is then the possibility of AK of becoming zero force member is not there. No, it's not like that. Once it determined as a zero force member based on one particular joint, okay, then it's zero force.
I see, sir.
Okay.
Thank you, sir.
Okay, good. Any other question for this? This particular, I will go through our homework problem one by one. Because for next week, right, the exam will only cover until class. Okay, everything from the beginning until class. So the frame that I will explain after this will not be covered in the exam. The first midterm exam, but it will be covered in the second midterm. Any other questions? No? Okay then. In that case, I will continue. Number 3. Who has problem with number 3? I believe at the beginning of the class, there is somebody who say that he has problem with number 3. Who at the beginning said that he has problem with number 3?
I did.
Who's this?
Aaron David.
Okay, Aaron. What is the problem, Aaron?
Just didn't know the calculation, I guess. I
Oh,
did the section, but I still only could find this one of them, I guess.
okay. Aaron, for this particular problem, we should use joint method or section method.
I think section would be more appropriate, I think.
Actually, both method we can handle this particular problem with both method. Yes, but it will be faster if you solve it using section method. Correct, right?
Yes.
Wait a minute. If you want to handle this with section method, okay, Aaron, where are we supposed to cut it?
CB, CG, and FG, I guess.
CB, C, and FG. Yes, correct. It's supposed to be like this. This is a section. That's our cutting line. And should we use the top three-body diagram or the bottom three-body diagram?
The top one.
The top one, because we don't want to solve the all the joints that A, J, and H. Okay,
Yeah.
so we're supposed to use the top one. In that case, you can draw for the free diagram, right? It's supposed to be this. Okay, and here is 90 degrees. Of course, it's 90 degrees L. Okay, then there will be the rest will become internal forces, and the cutting the cut member become our external forces. FCG, right? And FGF. FG. What is the question there? It's more to the geometry then for you, Aaron.
Sorry, sir.
This one is actually quite straightforward, right, Aaron?
I think I'm a bit confused about the FCG, I think.
FCG. Why you are confused about FCG?
Because the FBC is also affecting it. Yes.
The FBC, yeah, actually, you don't have to care about that. As long as you can solve the equation, it's supposed to be okay, right? So, based on this particular free body diagram, this one, based on this particular free body diagram, then you will be able to get three equations. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0, right?
Yes, sir.
This one is L. Okay, using these three equations, you will be able to find for the you will be able to find for all the member strengths. Okay, you'll be able to find for the all the members forces. This one, these three members forces, because we have three equations: 1, 2, 3, and we have answers: 1, 2, 3. Right?
Oh, yes, sir.
Yeah. So it's actually as simple as that. And what you should remember here is all the members there have the same length. So actually, all the triangles here has all the angles there is actually 60 degrees. This one. All of those there are 60 degrees. Okay, right, Aaron?
Yes, sir.
Okay, so then if you want to calculate, where are we supposed to start at using these three equations?
Pardon, sir, I didn't really hear quite well.
Okay, we have to use this equation, right?
Yes.
Okay, we have to use this equation to solve for this particular free body diagram. Okay, yep. And among
Yes.
these three equations, sigma fx, sigma fy, and sigma moment, which one they are supposed to use first?
You can use the FX first, yes, I think.
No, the best one is
Oh.
you use this one, sigma moment, and use it
The moment.
at point C. Actually, you can use any of those. You can use any of those in whatever sequence that you want. But this one is the best one. Why this one is the best one? Sigma moment is one, because by using that, then you will be able to solve for FFG there.
Oh, yeah. I didn't get FG, but the rest I'm a bit confused.
So
I I know about the sigma moment at point C, but the rest I'm a bit confused.
Okay,
How
then.
to
So
get-
you use sigma moment at point C, right? And then
Yes.
you will and you aim to find the value of FFG, correct?
Yes.
Okay, then FFG is settled. Then after that, you can use my FX and sigma FY. Not together, but one by one. Okay, in order to make everything easier. Okay, in order to make everything easier, I think the best possible way is to determine a new x and y for you. Because later it will be too confusing for you. So for me, I think the best way is like this. This is my y. And the x there, it will be parallel to this particular line. And this one as well. Do you get it?
Parallel with the
With EF, E and DC. So if you, yeah. So if you, this one, if I draw it here, it will be like this. This one my x, this one my y. Because by determining a new coordinate like this, it will ease the calculation.
Yes.
Okay. So later, when you use sigma fx equal to 0, then use as your x. So later, you will need to use cosinus or sinus for ffg and fbc. You get it?
So I don't need to use the sign for FG and BC.
Yeah, FFG and FBC. So later, if you use sigma fx, so then the first thing that we will use is sigma fx equal to 0. Right? For sigma fx equal to 0, L here is going to the y direction because of my new code, right? So I don't have to consider that. Do you get it, Aaron?
Yes, sir.
Okay, then FFG is going to the x direction. FBC is going to the x direction. So I must consider it. Okay.
Yes.
FCG is having a 60 degrees angle to the x direction. So I must consider it as well, right?
Oh, sorry, the FCG is
having a 60 degree angle. This one is 60 degrees. Okay. So my sigma fx equal to 0 then becoming like this. F
the FCG is 60 degrees against the X.
FBC, yes, X direction.
X. Oh, I see.
Correct, right?
Yes, I see it now.
Yep. So my sigma fx equal to become like this. FFG plus FG plus FCG cos 60 degrees equal to 0. But from sigma moment, you are already getting this value, right?
Yeah, yes.
Okay. Then after that, use fy equal to 0. Okay. By using sigma fy equal to 0, the FFG just now are going to the x direction. FBC is going to the x direction. So we can eliminate both, right, in the sigma fy. So the one that having which is going to the y direction is are only in this case is minus because going towards the opposites of the y, right? Minus L
yes.
and minus
FCG,
FCG. What is this then?
sine
Sine 60
Sine.
degrees equal to 0. Then you will be able to find FCG.
Oh, yes, yes.
FCG, you get it. You get FCG from this equation. Then after that, you can use FCG to this equation, right? Because FFG here is on already. So you will be able to find FBC, correct? Right?
Oh, yes, yes. Yes, yes.
You get it, right?
Yes, sir.
Good. So it's supposed to be clear, right?
I also have a question about the other thing.
Yes, of course.
Just for future reference, but how do you draw the external forces for the pins at the bottom? I'm a bit confused. The A,
Oh.
J, and A.
Identify those members for which the equation of equilibrium are not sufficient to determine their forces. Okay. Okay. The question here, we are not asked to find out the forces which is happening at these three planes. Okay, we are not asked to find out these three the forces which is happening at these three pins, because it's not possible. Because if we elaborate more, at A there will be AX, AY. At J there will be JXY. At H there will be HX, HY, right? So there will be 6 unknowns.
Only J1.
Correct, right, Aaron?
Oh,
So it is not possible to find those.
oh.
Okay. The one that is in question here is which of these member here that will not be able to be found. The forces will not be able to be found among all of the members there. Okay. These three members is supposed to be okay. This one is supposed to be okay as well. This one is supposed to be okay as well, right? So from the cutting up, everything is supposed to be okay. Now the one that is in question is the bottom one. Which of those members that is supposed to be able to find? Okay. After you out the CB, CT, and GF, and if you use method to solve for point B, can you solve it or not?
I think there's too many unknowns.
Too many, yes, correct. Because this one is not yet known, this one is not yet known, this one is not yet known. We have 3 unknowns, right?
Yes.
3 unknowns for one particular joint is cannot solve 3 unknowns. So we cannot solve joint B directly. Then, if we to solve for joint G, there are 1, 2, 3 as well. So we cannot solve it. That's why this one, those member, we cannot solve it because the equation.
Yes, I see.
So that's actually the question there.
In better.
Yeah. So actually, that's the last question there.
I just know for like future reference, if like the pin is in the middle of the truss, how to draw the forces.
The pin is in the middle of the truss.
J, so the J pin.
Oh, you mean pin is in the middle of the okay. So I mean, there is a pin there, but there is a truss there. Okay. So what you're supposed to do is you have to replace the pin with external forces. That's all. Jx and jy. Fa, ax, ay. Fh, h here, hx, hy.
Where does the Jx direction go?
Oh, in that case, depends on your this one. Depend on your reference here. Depends on your pin. If your coordinates like this, then AX will follow that coordinates. Y will follow that coordinate. JX will follow that coordinate. You get it?
So if I put the x-axis to the right, then it will go to the right.
Correct. If from the beginning you use X is going to the right and Y going up, then you will using it all the time.
So it's for H pin then, sir.
Sorry?
It also applies for the H pin then, sir. The HX also goes to the.
So it's like this. Actually, whenever we have a pin, or whenever we have if we have a pin like this, the components will be AY and AX, right? Supposed to be like this, right? AY, AX.
Yes.
But if you have a coordinate like this just now, okay, example, this one is our X accent and this one is our Y accent, and you can use this as well, your forces. AX accent, AY accent. This one valid because it's a pin, right?
Yes, sir.
If it's a roller, then this one is not valid because a roller, you have to have reaction force, external force, okay, going to the normal of the roller, right?
Yes, sir.
Yeah, but for a pin, you can do it this way. Okay.
But
You can do it this way as well. Sorry, Aaron? Yes.
But how about the direction of the action will be confused?
Yeah, it can be like this, or it can be like this as well. It's up to you. Which one that will is the collision? The same as this one, right? Just now we determine the X and Y here, like
Oh,
this.
yes.
Okay? In order to ease the collision, right? Aaron?
Yes, sir.
So basically, coordinate. You can use the coordinate, any kind of coordinate, which will ease your calculation. Do you get it there?
And what about the H pin? The goes to the right also then, or
It will, yeah. Once you use the same, once you use it for A and J and H, yeah, you can use. It's for you to use the same.
also the direction of the pin is always.
They're not necessarily. Normally, it's like this, right? The normal way is like this, Aaron.
Yeah.
But sometimes, if it's necessary to use this, then it's supposed to be okay as well. Hello.
Yeah, but I get it then. So.
So basically, you can use either of these two, which will ease your calculation. Because the coordinate is up to you. The coordinate is not up to me, but the coordinate is up to you. You can choose any kind of coordinate which will ease the calculation. If you use, for example, like just now, if you use coordinate like this, okay, if you use coordinate like this, right, X and Y, for this particular calculation, for this particular free body diagram, first body diagram, this one, okay, you use like this, for example, if you use that, okay,
Yes.
then the calculation will be too hard, right? I believe you do it, you already tried, right?
Yeah. I'm very confused.
Yeah, that's why it is better for us to use different coordinates which will give us easier calculation. Okay, much easier calculation. Correct?
Yes, sir.
That's the idea, actually. Okay, Aaron. Okay.
Okay, then, sir.
Hmm.
Thank you, sir.
Okay, no problem. Wait a minute.
Sir, I
Mhm.
have a question. Are all the answer expressed in
Expression what?
L variable?
What do you mean by express in L variable? Oh yes. Oh yeah. This one is correct. Everything is expressed in the L variables. Everything is in L. Sometimes we have a problem like this. Okay. Sometimes we have a problem like this. So everything here, all the answer will be in L. Yes. Okay.
And sir,
Mhm.
so L is supposed to determine or can be determined
Sorry. William.
because we don't know value, so the L is L can be determined or L cannot be determined.
L can be any magnitude. So later, for example, later you will be able to get, for example, FCG, right? FCG equal to, for example, VL. I haven't done the calculation, for example, but this one is just an example. Okay, FCG is equal to VL first. Hello?
Yes, sir.
Mhm. Something like that.
Oh,
So,
okay, sir.
why is okay? So for this particular case, right, William. So later, thoughts can be like this: FCG equal to VL, for example, or any kind of a number there, which resulted from the which your results as your calculation results. Okay, but it will be in L. Okay, hello, William.
Okay, sir.
Mhm. Any other question about number 3? Any other question about number 3? Oh, it's supposed to be clear enough. If it's clear enough, then I will go through number 4. Yeah, I believe it's clear enough, right? So then let's go to the next problem. It's number 4. Okay. Just now, who says that having a problem before?
Me, sir.
Who's this?
William.
Okay, William. What's your problem there, William?
All my answer expressed in variable h at, and I don't get the variable value.
You don't get
GX. Sorry.
GF. Okay, let's us go through one by one. The sine fast is designed to support a horizontal wind load of 800 pound force. If the resultant of this load passes through point C, okay, if the resultant of this load passes through point C, calculate calculate the forces in member B, T, B, and BF. Okay, then the first thing that you're supposed to do is to find out what the meaning of this. So basically later, your free body diagram will become like this. sorry, it's not a free body diagram, it's the new one. It's the new problem. Your new problem will become like this. Okay. This one, then there will be a pin here. There will be another pin here. Okay, something like that. This is it. And all the forces is supposed to be going through only one point. You get this right?
Yes, sir.
Okay, 800 lbf is actually going through to point C because of this. If the return of the fluid passes through point C. So this is the meaning of it. So this is the problem that was solved. Okay, now what is your question? We're supposed to find P and BG. PF is this one, BG is this one.
Yes, sir. I cut it, sir, at that point.
Then what is the problem?
The variable dx, sir.
It's
Pardon, sir. What you asked about?
wait. Just now the question is this one is PF and PG, right? So what is
Yes.
what's why you can't solve this particular problem?
I cut it, but all the
Where did you cut?
in BG, BF, and FE.
G, PF, and FE.
E.
Okay. Basically, you cut it like this.
Yes. And I take the lower part.
You take the lower part.
Yes, as the calculation.
No, I mean, how about AB? Have you solved AB? Have you solved
AB.
for AB?
Not that, sir.
Not yet. Then in that you cannot solve this then. The first thing that you're supposed to solve is here for these particular things, right? Is the external forces. Okay. Sometimes some of you will be confused about this kind of problem. If we take a look at this, right? At A here, it's a pin, right?
Yes, sir.
At G is a pin as well. So at G, actually, basically at G, we can list the force with Gx and Gy, correct, right? William?
Yes, sir.
At G, we can replace the force at point at pin G with Gx and Gy, correct?
Pardon, sir. What?
At pin G, this one,
In G. Yes, sir.
can we replace the pin with external force of Gx and Gy?
Oh, yes, sir. Yes.
Yeah. Then
Yeah.
after that, at pin A, what we're supposed to do then?
It is supposed to be X and Y also.
Ax and A, you mean?
And AX and AY, sir.
Okay, that's the question. Sorry, this is not the question. That's the problem. Because like at point A, actually it's connected to only this member, right? P, right?
Yes, sir.
Okay, and please tell me, William, what is AB? It's a two-force member, right?
Yes, sir.
Correct, right? AB is two-force member.
Yes.
If AB is two-force member, then the force which can be exerted by AB is either tension or compression, right?
Yes, sir.
Okay, then why don't we just leave AB and replace it with force at point B. Can we do that?
So we replace the AB to
Hmm.
the BF point.
Yeah. So basically, wait, wait. So basically, if I withdraw it again, right? If I draw it again here, this is my new problem. Okay. Since drawing is slightly, but still okay. Okay, like this as well. At T, I replace it with Gx and Ty.
Yes.
Can I do that?
Can, sir.
Okay, yeah. Then F AB instead of at A here, instead of replacing with AX and Y, right? I will delete, I will replace the member AB with external force. Okay, with external force. Like this. F A.
Yeah.
Can I do it that way?
Yes, sir. We can.
By doing so, okay, by doing it like this, and there is one external load of 800 lbf, right? By doing it this way, okay, we'll be able to find all the external. We will be able to find all the forces. FAB, GY, and GX, right?
Yes, sir. Oh, I see.
Okay. Previously, your main problem previously was you do the cutting without solving for the external force. You cannot do it that way, William, because one cut, okay, one cut like this, okay, by doing one cut like this, three members, okay, the unknowns there will be, right?
Yes, sir.
Okay, the unknowns there will be, but the other unknowns like if what is happening at A and what is happening at G, you haven't yet. So you can do the cutting, but after you solve for the external, you get it.
Yes, I get it, sir.
Yeah.
So, the main thrust we use to solve this problem is the lower or the upper part, sir?
Actually, the upper part, because the bottom part, if you cut it like this, right? If you cut it like this, the bottom part only with GF, right? Actually, you can use GF as well, but it's up to you, right?
So in my
So okay, let me check this one. Okay, the one that is in question is BG and BF. BF, B. Okay, the one that is question is this and this, right? So actually, you can do the cutting like this, right? Correct, right?
Yes, sir.
Yeah, but after you solve for FAB, GY, and GX, okay, GY, FAB, you have to solve it first. So the first step is solving for forces, FAB, GX, and GY. Then after that, you can do the, okay. The second part, the second is the cutting step, okay. After you cut it, okay, now you will left with two free body diagrams. The first one is the top one, okay, which consists of the one that is in red just now, okay, and the second one will only consist of this, right?
Yes, sir.
Will only consist of FG, right?
Yeah.
Only FG. F the external force, the rest will become external force. Right?
Yes, sir.
FPG will become external force, FPF will become external force, FEF will become external force. So Lee, your first free body diagram, sorry, the left free diagram, the top free body diagram will become like this. Okay, then we have FPG, FPG, then we have this one as well, FF. Okay.
Yeah.
This one. And we have FEF, right?
Yes.
Like this. FEF. Yep, this is the structure. So this is the top free body diagram. You have three forces there, and you can solve. You can use the top one, but you can use the bottom as well. But the bottom one will be only left with a member, GF. Yeah. GF only. Correct, right?
Yes, sir.
This one will be GY, GX. Then what else? FPC.
FPC,
Sorry, FPG. This one will be FPG.
Yeah.
FPG. What else? You have FPC. You have
FEF.
yeah, FPF. Yeah. You have FPF here. Okay, and you have FEF. Right?
Yes, sir.
So you can solve the bottom one or the top one. It's up to you.
Yeah. I get it, sir.
Hmm.
Thank you, sir.
Or you can solve for external force, then solve this problem using joint method as well. After you solve for FAB, FG, and GX, right? Then the one in question is PG and PF, right?
Yes.
PG and PF. Sorry. PG and PF. PG and PF, yes. By solving joint G here, then you will be able for you will be able to get FPG, right?
Yeah. PG.
And FGF, right?
Yeah.
Then solving joint F here, you will be able to solve for FP and FEF. So you can use section method, or you can use joint method there. And the calculation time will be more or less the same. Okay, you get it, Leon.
Get it,
For
sir.
particular problem, joint method or section method will be more or less the same. For most of them, yes. Sometimes joint method is better. Sometimes section method is better. Okay.
So the A point, we can change the AX and AY to be FAB, right, sir? To make it more easier.
No, we don't have to. We don't have to find out for AX and AY because at point A, the reaction force, like it or not, must be in the direction of FAB. Because AB is two force member, right? Because
Yes,
join like that will give only reaction force. So if the member only give a force FAB in the direction of AB, then at point A, the force will be in the direction of AB. That's why we can replace AB, we can delete AB and replace it using external force. It's always that way. Okay. The same as this one as well. Which one? This one. ED there. Okay. E there. You can just replace it with external force, FED.
Mm.
Do you get it, William?
Yes, sir, I get it.
So our free body diagram to solve for the external force, it can be like this. Okay. It can be like that. Yes. This one, yeah, meeting point. Yes, 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 yes. And at A, there will be XAY. This one is to solve for F forces, okay? Then there will be FEG like this. Okay?
Okay,
In
sir.
order to solve for the external forces, you can just use technical free body diagram. Nah, not yet. 3000 and 1000 you scroll it is as well. Okay?
Yep, sir. Okay.
So basically, whenever you have like this, right, member which directly only one member is connected to one particular joint, one particular pin like this. Okay, you just delete that member and replace that member uh, with the force which representing that member, like this. Okay, so this is for everyone. You get it, William?
Yes, sir, I get it.
Okay, number four is supposed to be okay. Anyone here having a problem with number 4? Supposed to be okay, right? Then Matthew, do you still have problem with number 4, Matthew?
No, sir.
But you understand my explanation, right? About this one. Hello, Matthew.
Number 2, sir.
Okay. From number 1 to 4, who still have any problem?
Sir, sometimes I still don't quite understand how to know whether it is zero force member or no.
Basically, what you're supposed to do is just to follow the explanation that I give you before. For example, like this. Share screen. Okay. Top share. Okay. Okay. Remember for my explanation before. Can you see this? Asad?
Yes,
So
sir.
zero force member. So basically there are two types of zero force member. The first zero member is the one which follow this. Which follow this explanation. This is the first type of force member. The example is like this. AF, AD, ED, and DC. Okay, those are zero force member. Okay, the second type zero force member is the one which follow this particular rules. For example, AD and AC here. It is zero force member. Okay, so basically, Basically, zero force member is kind of member that's supposed to be there. We cannot delete it. But based on the loading which is given in the problem, that particular member exert no load. That's why we consider zero force member. But for other type of loading, there is a possibility that that particular member will not be zero. So everything depends on the load which is happening on the problem. Okay, so there are two types. The first one is this one, where two collinear members met at one particular joint. Okay, those two collinear members must be forced. Okay, and the second one is when we have members joining at one joint. Okay, and those members are collinear. Okay, the non-collinear one, this one, for example, AD, and this one, DC and B is collinear, right? AC, okay, in this case it's AC and AD. Those two will be zero force member. Okay, so
it's
only two
not-
types. Only two types.
Okay, so in this part, if there is two collinear, and in the middle or somewhere between that two members, that two collinear members, there's a non-collinear one. It is a
The
zero.
the non-collinear one will become zero force member. Remember, it's only if three members are in at the one joint and there are no external force at that particular joint. If there is an external force, for example, D going like this here, FT going like, right?
Yes.
AD will not be zero.
Okay.
Okay.
Okay, sir.
So there are actually only two kind of zero force member. This is the type. This is the first type. Okay. And this one only applied if there are no external forces there. If there is an external forces at joint A like this, F and AB most likely one of or both will not be zero force. You get that?
I'm sorry, sir.
So this one is another explanation. If there is an external force at point A, okay,
Yes.
AF and AB, which is if there is no force, is zero force member. Okay, then if there is an external force there, okay, one of those or both can be non-zero force member. Okay.
Okay.
And another thing that you guys must understand is once a member are determined zero force member, for example, AF here is zero force member, AB zero force member, from one particular joint, here, joint A, then if you look at joint B and you think there is not zero force member, it will not affect that. It will be zero force member. So determination of a zero member or not, okay, determination of zero force member or not is actually just based on one joint on. Do you get it, Asa?
Yes, sir.
Good.
So it will not affect other joints. It's only affect.
So no. It will affect other joint. The member will affect other joint. But if you take a look at joint A and you determine AF, AB zero force member, R zero force member, then when you take a look at joint B, oh, you think that your conclusion is wrong. On joint B, there is a possibility that AB is non-zero member, not zero force member. You cannot do it that way. Once you determine as zero force member, then it will be zero force member. So if from one join is zero force member, then from another join, you cannot change it.
Oh, so both
get it?
in both joins in A and B, in the AB force two force member, it will be a zero force member.
Yes, at B as well, it will be zero force member. But the problem is sometimes some of you think this way. Okay, when I take a look at join B, AB is not zero force. When I take a look at join F, AF is not zero force. But when I take a look at join A, oh, it's zero force. So which I supposed to pick then? Whether it is zero force or not? Then the answer, it will be zero force. So the determination of zero force member or not is just based on one join. You get it? The same as this one. If you take a look at join A, AD is not zero force. AC is not zero force. When you take a look at join D, AD is zero force. When you take a look at join C, AC is zero. That's why AD and AC must be zero force. So the determination is just based on one join is enough to determine that it's a zero force member.
Oh.
So you don't have confirm it with another join because it will not be possible to do so. Okay.
Okay. So in the number 2, that we use the first zero force member, yes, sir, in the homework.
Homework. Wait a minute.
In the number 2, we use the first zero force member, yes, sir.
Your homework.
Yes.
Number 2. Number 2. This one, yes. This and this, okay. JK and AK is actually the first type of zero force member, but BK is the second type of force member.
Oh, I see.
Okay.
Okay.
Good. And FH there is not zero force member because there is an external force 3000 Newton point each. If 3000 Newton is not there, then FH will be zero member. Okay.
Okay.
Then the last one, number. Seems like most of you are having a problem with number 5. Anyone here can solve number 5 without any problem? Anyone? No one here? Force P is given to the thrust structure as shown below. Please determine the force nature and direction that happen into force member AD. FAD, only FAD. Okay, seems like FAD are having a problem with this particular problem. Okay, so I'm telling you guys that this one is the what you call as the some kind of a little bit complex one. Okay, we cannot determine the we cannot determine the load based. We cannot determine everything based on just the equation. Okay, we cannot solve everything just using the equilibrium equation. Okay, the normal equilibrium equation. So we consider this as a statically indeterminate problem. Actually, it's not statically indeterminate, but it's quite close to statically indeterminate problem. Okay, so how can we solve this problem? Okay, the things that you can do is to divide this into two. Okay, you can divide this into two different free body diagrams. Okay, I will explain it to you. The first thing that you're supposed to solve is this one, joint P there. Okay, all the angle here is 45 degrees. So at joint P, then you can solve for this one. Okay, using joint method at H, there will be F. This one is P, this one is F, CH, this one is F, GH. Okay, this you will be able to solve for CH and GH, right? Because we are using joint method P here, so everything will be in P. FCH will be in P, GH will be in P. So you can solve for CH and GH. Okay, the next thing is CH and GH will become your external force. So now the system that we're supposed to handle, the system that we're supposed to be handling, will become like this. Okay. CH, FGH. But remember, you are already solving GH and CH. So this one is the known value. And now here we have okay, now here we have Y, AX, EY, EX. Okay, CH known, but AX, AY, this one AX, this one EX, EY, these four values are not yet known. So we will not be able to solve this directly. So what you can do after this, okay, is to divide this problem into two different free body diagrams. How to do it? You can do it this way. Okay. So here we have FCH, which is known already, known value. AY, not yet known. AX, not yet known. Okay. Then because I release this to two. Sorry, FGH here known value. EX, EY is not yet known. Okay, but because I release this into two different free body diagram, okay, I release it at this particular point D. Okay, then at point D, there will be force there. Like that. Force which is happening at joint D. Force which is happening because I release both into two system. Now The unknown value here will be this one, this one, this one, this one, dx and dy. Okay, in total, okay, in total, we have six unknowns. Ax, Ay, Ex, Ay, Ex, Ay, Ex, Ey, Dx, Dy. 6 unknown. And in total as well, we have 6 equations. 3 from the first free-body diagram, another 3 from the second free-body diagram. So we have sigma fx1 equal to 0, sigma fy1 equal to 0, and sigma man 1 equal to 0. That's from the first free-body diagram. And from the second free-body diagram, we will have sigma fx2 equal to 0, sigma fy2 equal to 0, and sigma moment 2 equal to 0. This is from the second free-body diagram, and this is from the first free-body diagram. 6 unknowns, 6 equations. You will be able to solve it. Do you get my explanation, guys? Hello? William, do you get my explanation, William?
Yes, sir. I get it, sir.
Meryl, how about you?
Yes, sir.
Do you get my explanation?
I'm still processing, sir.
Okay then. So later it's better for you to watch the video. Okay.
Yes,
How about you, Matthew?
Hello, sir.
Hmm?
Yes, sir.
Hello, Matthew. Do you understand, Matthew?
Yeah, hello, sir.
Yeah. Do you understand my explanation?
Yeah, but I don't know why you find dx dy for.
Dx dy, like it or not, we have to find it. It's actually the force which is happening because we release the left system and the right system. So the force happening at point D. So the action and reaction which is happening at point D. Do you get it? So when you join it together, dx and dy will not be there because it will be canceling out each other. Dx from the left one and d and dy from the left one, dx and dy from the right one. Actually, both are in the opposite direction because it's action and reaction. That's why when you join both systems, it will be gone. There is no dx and dy here.
What I'm confused is how do you find AD from dy dx?
Oh, how to find AD from dydx? No, you don't find AD from dydx. You find AD from ax, ay. Join A.
Because for my homework, I use a different method. I use joint method.
What kind of method that you use then?
So I looked at joint H.
Mhm.
I found H, CH and GH.
Yeah, correct.
Then I take a look at G. Yeah, point G.
Mhm.
And using sigma fx, I'll get dg.
Okay.
I'll do the same.
Okay. Oh, you use join method. Okay. If you
Yeah.
use join method, then you will be able to solve this. You will be able to solve this. Then after that,
After
BD
that, I
is
look
zero force member, TE is zero, TF is zero member, right?
yeah, like that.
Okay, but after you solve this and this, okay, you solve this, then you try to solve point D, right?
Yeah, correct.
Okay, can you solve it?
I did get an answer, but I don't know if that's correct.
Okay then. In that case, try to check it with a solution whether it's correct or not.
Where's the solution, sir?
I mean, try to do like what I explained just now and compare it with your previous answer. Do you get my point, Matthew?
Actually, not really. But with AX and AY, how do you find AD? Is it just
why join method? Join method at point A.
oh, so AX costs 45 is AD. Yeah. Is it like that?
AX. Wait a minute. This AX cost 45. Yeah, actually, what you're supposed to do is just using sigma fx and sigma fy at point A. Okay, so AX AD cos 45 will be AX.
Oh, yeah. Sorry, my bad.
Okay. So you can try to compare it. So this one is supposed to be the one that has you're supposed to divide it into two because the system is actually we cannot solve it directly like that. But by join method, I believe the answer is supposed to be correct as well. So basically, both answers supposed to be correct. Okay, so it's better for you to try both. Okay, Matthew.
Okay, sir. Thank you, sir.
Oh, okay then. I think I don't have time to solve for to explain about the frame. So on today I will explain a little bit about the frame, a little concept about frame, and on Friday we continue the discussion about the frame as well. But on Friday, if you have a question about fast, then we'll answer that on Friday as well. Because remember that our exam will be next week at Friday. Okay, sorry, next week on Friday at night.
7 p.m., right, sir?
Yep, yeah.
PM?
Yeah, PM, not AM,
Okay.
PM. AM is our class, right? So the exam will be at night. So we still have class in the morning on Friday. So Friday morning we will still have class. At night you will have your exam.
Should we? I mean, do we have a substitute class because yesterday holiday?
I don't think that it's super. I don't think that it will be necessary. But maybe later when we need to catch up for the second midterm exam. But for the first midterm exam, I think it's supposed to be enough because all the explanation, all the problems, I already give it to you here. Maybe I will give you some additional homework today of the trust. Okay, several additional problems for you to practice more for the exam. Okay. Next week we will start for the frame, but frame will not be part of our exam. Okay, so the exam, the topics that will be covered in the exam will be from the beginning until trust. Okay. I think it's supposed to be all clear. Then I think that's all for today. Oh yeah, don't forget to don't forget to mark your attendance. Okay. I think that's all. I think see you guys week on Thursday. Okay. Bye bye. Thank you for this.
Thank you, sir.
Thank you very much,
Bye
sir.
bye.
Thank you, sir.
Thank you, sir.
Okay. Bye.
Yes.